Michael with Michelin Metals, back again for video 2 of the new year. New year, new metals to talk about. Before that though, how about you help me out? Whoop, click that little subscribe button right there. Just bink, just click it. It'll help the channel out. If not, drop a quick thumbs up, like the video. Appreciate it. So for the next several weeks, the topic will be alloy steels. Aircraft quality alloy steels to be precise. So what makes a steel, specifically an alloy steel, aircraft quality, aka AQ, versus CQ, commercial quality? What's the difference? There's plenty of alloys that share both of these different types. We got 4130, 4340, 4140, 8620, 9310, and 52100. And so what's the difference? Well, let's find out. First, some things we know about aircraft. Weight is important. So parts need to be made as light as possible. And as a result, they tend to be highly stressed. Also, they operate in temperatures well below zero at altitude and can be subjected to impact loads or cyclic loads that can cause metal fatigue. Failures are at a minimum very, very costly to repair, or catastrophic beyond all repair, and people get hurt or worse. And so when I say check the spec, I mean it. Now, the key to performance of these critical parts is the micro cleanliness. That is the elimination of microscopic flaws that then allow us to safely use the steel at high and cyclic stress levels. Specifications require confirmation that the cleanliness has been achieved. So, for an example, let's look at the differences in production and requirements between a commercial quality CQ alloy steel and an aircraft quality AQ alloy steel. It all starts in the melt shop of the producing mill. Chemical analysis of an AQ alloy restricts the phosphorus and sulfur to a maximum of 0.025% each. The CQ alloy maximum is 0.035 max for phosphorus and 0.040 for sulfur. Reducing these elements reduces the formation of nonmetallic inclusions in the steel. Vacuum degassing takes out dissolved gases like oxygen in our AQ alloy to further reduce any inclusions formed from the melt during solidification. CQ alloys would not require vacuum degassing. AQ alloys require additional tests performed at various stages of mill production. Tests are conducted on samples that represent the first, middle, and last portion of each heat cast to verify physical soundness and to verify the micro cleanliness. A macro etch, aka macro test, to look for physical flaws like cracks and voids on samples of the full cross section. Machine samples are used to verify the micro cleanliness of this steel using the AMS 2301 magnetic particle inspection. Inclusions are limited to a maximum frequency, how many, and severity, how large. How many and how large are permitted. That is what 2301 will tell you. It'll tell you the limit to all of those inclusions. This inspection at the mill confirms the capability of the heat lot to meet the requirements of final inspection conducted after manufacture of finished parts. Additional requirements and types of tests and inspections are contained in the various AQ specifications. Aerospace Material Specifications, AMS, MIL, and various other aerospace companies like Boeing, Pratt & Whitney, GE, etc., so on. So as always, we say, check the spec. So thanks for watching, and if you made it this far, guess what? I know something. I know you like metal, because you wouldn't be here this long if you didn't. You'd probably be sleeping. But thanks for watching. This is Michael with Michelin Metals. Please subscribe if you haven't. And if you've missed anything else, there you go. It's Michael with Michelin Metals. Thank you for watching. I am out.